Headshot.
In this section, we'll be adding a wall slide mechanic to our character controller. So what exactly is a wall slide? With a wall slide, we can have our character cling to a wall and slide down it. And really, this mechanic makes the player feel more connected to the game world. So rather than a wall just being a boundary that the player can't go past, the player is now able to use it to navigate the game world. There might be a big pit in the ground, but there's walls on the sides of the pit. And rather than just having the player jump directly down the pit, he could jump and slowly slide down the wall just to more cautiously go down the pit. So if you think about a lot of the popular and successful 2D games, especially Super Mario Brothers, obviously, the newer Super Mario Brothers have a wall slide mechanic where Mario can slide down the wall slowly, and of course he can jump off the wall. So this mechanic adds a ton of fun to your games. Once again, gives control to the player, allows for the player to more easily explore your game world. So let's go ahead and talk about how we might implement this mechanic in the next video. Let's quickly discuss a few different possible ways that we could implement our wall slide mechanic. One possible option would be to do something similar to what we were doing in the ground checker script, and fire raycasts left and to the right of the player to check for terrain. But can you think of any possible issues with choosing this route? The raycasts are just thin little lines, and so the question is, how would we know exactly where the raycast should come out from the side of the player? Should it be, directly in the middle as far as the Y position on the player? Or should it be up higher towards the shoulders or down towards the feet? And if, for example, if our player starts wall sliding at the top of a wall, then the raycast might not actually hit the wall until the player has fallen farther down the wall. So another option is to instead just use a trigger collider. So we could have a box collider 2D that's set as a trigger, and that can be taller, and it'll take up kind of more space all along the sides of the player rather than one little thin line. That'll give us more coverage, and I think it'll be more consistent for detecting a wall and a wall slide. So let's go ahead with that method and let's get started. To start our wall slide mechanic, the first thing we need to do is to have a way to detect if the player is physically colliding with a wall, or if he's close enough to a wall that we should consider that he is touching it, and therefore we can decide that he should wall slide. So first thing that we can do is let's click on our player game object and expand. Now we already have our ground checker. We're going to add a new game object, and so right click on your player and do create empty. And this game object we're going to name wall checker. Now, what we're going to do is add a box collider 2D that will be able to poke out from the sides of the player and detect if we're touching a wall. So let's add a component, and you can go to Physics 2D, Box Collider 2D. Okay, and you'll see that it has a default size of 1 by 1. And if you look under the component properties, here's the size. Let's change the X to be 1.3. So that extends the X width out a bit here so that it's farther out from our player. So let's go ahead and play and see how this acts. So you'll notice that as our player moves and tries to collide with a wall, it's colliding with this new box collider that we've created. And so it's making it so the player itself is not hitting the wall flush like he was previously. And you can see again that I'm getting stuck on the wall, and that's because this is a new collider that has no physics material, so it has that default friction property like our player used to have. Okay, so that's not quite acting how we want, so let's stop playing. So the solution that we want to use is the box collider 2D and most collider components have a property called isTrigger. So let's check that box. And what that box does is it says, I want this collider to detect collisions, but I don't want it to physically collide with things. So if we play our scene again, you'll now notice that our player is able to be flush with the wall again. He's able to slide up against it. So even though this new collider is not physically stopping the player from hitting the terrain, it's still going to detect the collision with the terrain when it overlaps with it. So that way we can still have that message sent to our script, and we can know if the player is close enough that he's considered touching the wall. Perfect. Alright, we'll go ahead and get coding next. Similar to how we have our ground checker set up, we now want to make a new script specifically just for the wall checker that we can add to this wall checker game object. So let's go to our scripts folder and right click and do create C# script, and we're going to name the script wall checker, and go ahead and double click that to open it in your script editor. Okay. And let's clean out the auto-generated methods here that Unity made. Now, what does our wall checker script need to do? Basically, we're going to be putting it on the same game object. Let me pull Unity back up here. We're going to put it on this wall checker game object, which has this box collider 2D component, and we want to be able to receive events that this box collider 2D sends out. So Unity has some built-in methods that we can take advantage of here. The first one is onTriggerEnter2D. So we'll say private void onTriggerEnter2D. My code editor auto-completes it for me, but you'll notice that it takes a collider 2D parameter there. So this method is saying when our trigger enters a collision with another collider, then fire off this method, then any code inside of this method will be executed. And then another similar one is there is a onTriggerExit2D. So we'll say private void onTriggerExit2D. Takes the same parameter. Okay. So now we know when our trigger has collided with something and when it stops colliding. So now what do we do with that information? What we want to do is, let's go over to our character controller 2D script, and we're going to add a new property here that we can update from our wall checker. So let's make some room underneath our jumping area here, and we'll make a new header that we'll call player state. And let's make a new public boolean, and we will call it isTouchingWall. There we go. And then go ahead and save your script. So now that we have this property, we can get a reference to it inside of our wall checker script and update it. So we need to make a new public reference here to our character controller 2D. So we'll say public character controller 2D, and then we'll just name it character controller. Now inside of our onTriggerEnter, we can say character controller dot isTouchingWall equals true, and then of course in the onTriggerExit we will want the opposite. Character controller dot isTouchingWall equals false. Perfect. Let's go ahead and save this. Then let's go back to Unity. Once it's done compiling our scripts, make sure you've selected the wall checker game object, and we now need to add this script as a component. So you can drag it or use the add component here. And here you can see our public character controller reference that we want. So you can click and drag player onto that, and it'll make that reference for us. Go ahead and save your scene. It's always good to do that frequently. And now let's do this. Click on your player game object so it's highlighted, and you can scroll down and see there's our new isTouchingWall boolean, and let's go ahead and play our scene. Okay, and you'll see it's not checked right now, but if we go down and stand next to a wall piece, where our new box collider is indeed overlapped with the terrain, you'll see that is touching wall is set to true. And when we leave, it's no longer set to true. And that happens on both our left and right sides. Perfect, that is exactly what we wanted. Okay, now that we are detecting when our player's touching the wall, we can move forward. We've made progress on our wall sliding mechanic, but there's a few more things that we need to consider before we can finish it up. Let me play the scene here. And you'll notice with my player here, if I am just standing next to the wall, then my is touching wall is true, which is what we want. But in this case, we also don't want to consider the player wall sliding because he's just touching the ground. He's standing right next to a wall. He's not trying to do a wall slide, he's just standing next to the wall. So we need to know if the player is touching the ground. So that way we can say, okay, I know the player is touching the wall and that he's not touching the ground. Therefore, I want to do a wall slide. And the one other thing that we need to know is if the player has a negative y velocity, meaning he is falling, because we don't want to do a wall slide on the way up on our jump. We want to do it on the way down. So let's stop the editor here. Now let's open our character controller 2D script. And we are going to add a new public bool under our player state area here. Let's make some room. And we'll say public bool. And this one we will call is grounded. So this is just a simple property, is grounded, is the player touching the ground. That simple. So let's save our script. And now we need to open up our ground checker script that we haven't touched in a while. Alright. Now what we can do is we can use some of the code that we've already written here. For example, down here we're checking, did we hit anything? Did we hit the terrain? Yes, reset our jump. Okay, and we already have a reference to our character controller 2D script. So first thing that we can do is inside of this if conditional, let's make a new line. And now we can say character controller dot is grounded equals true. So if we did collide with the terrain, then obviously we should be grounded. We're collided with the ground. And now we want to add an else statement. We didn't collide with anything, so we must not be touching the ground. So we want to say character controller dot is grounded equals false. There we go. And then one more thing that we want to do is, this is just kind of a safety check here. We have our code here, don't check for ground if player has an upward velocity. So let's add some brackets here. Put our return statement inside of here and add a new line. And we're just going to add this to ensure that if our player has an upward velocity, we definitely don't want to say that we're touching the ground. So we'll say character controller dot is grounded equals false. You can add a comment here. We can't be touching the ground if we have an upward velocity. Perfect. So, and if you're not familiar with C#, you can have an if statement, and if you just have a single line that you want to execute inside of that if, you can just have it underneath like we did previously, like that with return. But now that we have multiple statements, you have to use the curly braces. Okay, let's save our script. Now let's head back to Unity and we'll check it to make sure it's being set correctly. So select your player game object again, scroll down in the inspector, and we now have our is grounded property. Let's play. Okay, you'll see we're touching the ground, is grounded is true. And go ahead and jump. You'll notice it gets turned to false right when we jump and right when we land. So we've got another piece of information that we needed to complete our wall slide mechanic. So now we can move forward. We now have all the information that we need to finish up our wall sliding mechanic. So let's open up our character controller 2D script. And before we get started, let's scroll down, and I want to do a bit of housekeeping real quickly. You may have already gotten rid of this commented out code, but I'm going to do that in mine just to clean up this script. So that was code that had to deal with the option of using add force to control our character controller. So if you want that code still, you can of course look at the previous videos. Okay. And then I also want to move this rb.velocity statement. I'm going to cut that and paste it down at the bottom of our handle player input method. And the reason I'm doing that is just to make it cleaner so that up above we can do our calculations to determine what our velocity or force should be. And then when the dust is settled, then the last thing that we do is set the velocity. That just makes more sense in my mind. Okay, now let's scroll up to the top and we'll get started adding some new code. First thing that I want to do is add a new player state property. This one we will call, it's going to be a boolean as well, and we will call it is wall sliding. So is the player currently wall sliding? Then up above this player state, let's add a new header, and we'll just call it wall slide. So any properties and variables that we want to add that deal with the wall slide we can put under here. And the one that we need to add right now is we want to have a property that tells us what the velocity of the player should be as he is wall sliding. So we'll say public float, and we will call it wall slide acceleration y. I'm going to set its default to -1.0. So this is going to be used as the constant value that our player is falling on the y velocity when the player's wall sliding. So that way he'll have a nice, smooth, constant falling velocity. Okay. Now the next thing that we need to do is go down to our handle player input, and we need to finally actually determine if the player is wall sliding at the moment. So let's make some room in between our movement and jumping here. And let's add a new comment for wall slide. Okay. So if you think about it, like we talked about in the previous video, the information we need to know is, does the player have a negative y velocity, meaning he is falling, and is the player touching the wall? So we'll say if rb.velocity.y is less than 0, so our player's falling, and is touching wall is true, then we know that is wall sliding is true. Else is wall sliding is false. So if we're falling and touching the wall, we should be wall sliding. Otherwise, we're not wall sliding. So it's that simple. Now that we have that information available to us, it makes it really easy to determine if we are wall sliding or not. Okay, so we finally know if we should be wall sliding, and we can now add the code to actually perform our wall slide mechanic. So let's move down underneath jumping. We're going to add an else if to the bottom of our jump conditional. So we're not jumping, otherwise check if we are wall sliding. Is wall sliding. Now we can say rb.velocity equals new vector2, and we want to maintain any existing x velocity. So for x, we'll simply pass rb.velocity.x, and then at this point we now can reference our wall slide acceleration y for our y velocity. So this way, even if our player has a huge negative velocity, he's falling really fast, but then he starts to wall slide, it's going to zero out, and it's going to just set the player's y velocity to our wall slide acceleration y, and we'll have a nice, smooth, and consistent wall slide where the player is slowly falling. Okay, so I think that is all that we need to do in our script here. So let's make sure to save it, and we'll now return to Unity, and let's play our scene and give it a try. Okay, I'm going to move my player down here, and now I'm going to jump at this wall, and you'll now see that my player moves slowly down the wall. And of course, when I jump on the upward acceleration, it doesn't slow the player down, which is how we programmed it, because we only want to perform the wall slide when the player has a negative velocity on y, meaning he's falling. So we fall nice and smoothly when we're touching the wall. Otherwise, if we're away from it, we have our normal standard jump. So there you have it. Now, it might not look like anything super special right now, but this is a nice solid wall slide mechanic, and once you add some graphics to this, some visuals of a character where he's up against the wall, maybe with his hands, and he's sliding down the wall, and there's dust particles shooting off the wall, it really makes the wall slide come alive and makes the mechanic feel that much meatier, and it'll feel great. So I'm glad that we finally have our wall slide mechanic built out, and next we'll move on to our wall jump.